down the line. And that might help whether or not is to hold that question until that time or to go ahead and get it out. That would be a strategy that we could use at this point to really make this the most efficient process.
Very true. Thank you, Cash. So let's move on. To learn the math facts, see, it was interesting to me that kids come in the first grade, we give them spelling words and we don't teach them how to do that. Then we also teach them math facts, like how to add and how to subtract. And then in the third grade we go to multiplication facts, and in the fourth grade we go to short division facts. And many kids don't wire those things in so that they're automatic. And if you don't have those automatically wired in, then you can't go to higher level math strategies because you're sitting there counting on your fingers or something like that. So I always say to the kids that come to see me, I say, do you play any sports? And they might say, well, I play basketball or baseball or something like this. And I said, well, let's go out in the driveway. I've got a basketball goal over my garage, and let's play a little game of horse. It's a game that kids know how to play. Except that you're handicapped. You've got to cover your eyes with a blindfold. And they say, what? So you got to cover your eyes with a blindfold. Will you be handicapped? And they go, yeah, I'll be handicapped. I go, well, that's how you're handicapping yourself in school. You're not using your wonderful ability to make pictures. You walk into the classroom and you say, okay, I got to leave my picture making out because I'm now in a classroom. Then I say, if I ask you to play basketball on your knees, will you be handicapped? And I said, well, yeah. And I said, well, if you don't have your math facts wired in like this, you're handicapped whenever you start doing higher level stuff like 5th grade, 6th grade, 7th grade math. You've got to have, it's one of the sub skills that you've got to develop. And so this is the way that I teach them to do it. And I'm sure most of you will recognize the math triangle, math fact triangle. This, by the way, is from Michael Grinder, for those of you that know who Michael Grinder is. When I wrote my book, I didn't know where it came from. It was one of those anonymous sources. And since then, he told me that he's the one that developed this. So. And notice how the strategy that we're going to do is going to fit the memory stuff. So I usually will ask them several things to see what they know. So I might say, what's 7 times 8? What's 42 divided by 7? What's 9 times 8? Just to see how fast they are. That's one of the ways I do the assessment. Once I find one that they don't know, then I say, okay, let me show you. And on a piece of paper, I'll draw this triangle. And then put like 7 times 8 with the times there and the divide there and the 56 up there. And I'll show it to them. And I'll say, I want you just to look at this and remember what it looks like. Remember the picture. This must be Cat. Hi, Cat. Everybody say, hi, Cat.
Hi, Cat.
Welcome, Cat.
Welcome, Cat.
So they all say, they just look at it, and then what I do, and watch, I want you to watch the preciseness of this. I can pretend you're the student. So now I turn this over. And I say, okay, here's the triangle. Okay. Right here is the times sign. There's the divide sign. What's this number over here? What's this number over here? What's this number up here?
56.
So it goes like this. 7 times 8 is what?
56.
56 divided by
8.
8 is?
7.
Okay. You said.
8 times 7 is 56. 56
Divided by
7 equals 8.
8.
8
Divided into? Divided into? 56.
56.
Let's do that again. 8 divided into 56 is 7. Now, what's 56 divided by 8?
7.
What's 7 times 8?
56.
What's 56 divided by 7?
8.
It's always that other number, isn't it? You ever notice that? Now, the beauty of this is kids love it. I mean, they absolutely love it. And it is something that works so very well. So, and if you stop to think about the structure of it, in case you know something I don't know, there is no triangle here, right? There is no triangle here, right?
Oh,
This is an illusion. So what does that mean that they're having to do? They're having to picture it inside their mind. And when I say, now what's this number over here? What's that doing? It's connecting the sound of that number to the picture of that number. And then when I say 7 times 8 is 56, that's connecting the sound of the actual math fact itself to the picture of the math fact. It is cool. It is really cool.
And then you do that with every,
And then you do that with every one of them. I'll give you an example of how cool this is. I don't know why I was doing this, but I was invited to visit a emotionally disturbed class. I think that's what they call them. It's where they put the kids they don't know what to do with in it. And these were like 7th graders. So it's very active. They were all boys, 8 boys. And so when I walked in, and I don't know why then, but I had a suit and a tie and all that type of stuff on. I don't usually wear that anymore. I had a suit and tie, and so I looked kind of ominous, I guess, probably. Sat down in the corner of the classroom, and they were absolutely berserk. I mean, they were all over the place, running around, hitting each other and throwing spitballs and all sorts of things, and yelling and talking and arguing and doing all sorts. And the teacher was up there screaming at them, try to get down and get your lesson done. Just totally out of control. One little guy sat down and he opened his math book and he was wanting to do it, and he said, "Teacher, I don't know how to do these problems." And she had an assistant, by the way, and so she'd be working with this side of the class, and this side of the class would go crazy. She'd go over here, and this side of the class would go crazy. It's totally out of control. So this kid said, "I don't know how to do these math things. Can you help me?" And of course, she was trying to control the class, and she said, "Well, Dr. Blackerby is a math teacher. Let's see if he'll help you." The guy kind of looks at me, funny. And then after a while, he comes over, and he says, "Can you help me with my math?" And I said, "Well, let's take a look at it and let's see what you're doing." And he was into multiplying or adding fractions or something like this, and so and he couldn't do it. And it became obvious to me that he didn't know his math facts. And so I said, "Let me check you out." And so I checked him out on a few of them. I said, "Before you can do those type of problems, you need to know your math facts. Let me show you a real neat way to learn them." And so I got out some pad and pencil, and I started doing some of this with him, showing it to him, and he was just picking it up like this. Within 5 minutes, all 8 boys were right there in front of me, and they were all competing with each other for who could do it the fastest,
Exactly.
Now, you talk about a metaphor about the difference in having learning strategies that really work, and having a school building or a classroom that is where you're just doing mundane, boring work and stuff like that. So I think the reason this stuff does so well is because the kids know it's going to work. I mean, they instinctively know that when they do it the first time. Yes, Ben?
Maybe it's a simple question. What's the math facts?
What are the math facts? Math facts would be all your times tables. Does that make times tables or division tables, short division tables? It's like these, where you see them like 7 times 8 is 56. 56 divided by 7 is 8. Those types of things.
Addition, subtraction, division, multiplication, other facts, or anything else?
No, just those. Just those.
Actually, don't I try the
Let's
method?
say little ones, adding and subtracting.
It works on adding and subtracting.
7 plus 8 is 15, 15 minus
Sure.
8 is 7.
Yeah, so if you do it this way with addition, it's like this. So if you have 6 and 7 and 13, then you go 6 plus 7 is 13, 13 taken away 7 is 6, 6 taken away 13 is 7, etc. So what you're doing with this one, and I've had students learn all their multiplication facts and all of their short division facts in a week. It takes in school all 3rd grade and all 4th grade to do that. They can do this in a week too. Don't do them at the same time though. And it takes all 1st grade and all 2nd grade to learn the addition and subtraction facts in school. Yes, Finn?
That triangle, is that common in the American?
No. Not until I came along.
Well, I don't know.
Is it common now?
No.
So, all this stuff that we've learned about the importance of comprehension, of, what am I thinking of? Cognitive comprehension of what does it really mean when you multiply and divide. I'm assuming that
That's something else.
it's something else.
Yeah.
It doesn't need to be in place. It will come wherever it comes.
Yeah, you got to have this foundation before you start developing strategies for how to learn math and how to conceptually do math and stuff like that. And this is one of the basic stumbling blocks of many students in math because they don't know this.
They don't know this, and then so then they're blocked.
Right.
So
Absolutely.
it's the opposite of what we've been with the math their way and all that, making sure that they have it in their system.
In
first,
my-
and then
In my humble opinion, yes, you got to know the sub-skills before you can do the big stuff.
I got it.
Okay.
When I was in school, I remember that we had the covers of our notebooks and the back,
Yeah.
like the
Right.
matrix, and you know,
Multiplication.
and just by having it somehow and teaching one another, do you know that one when we found the difficult one?
Mhm.
You know, this made us practice visual.
Yeah, did you sleep on it so it would really soak in?
You know, like as a game, when you didn't
Yeah.
know what to do, you were coloring it and adding some structure to it.
Yeah, in fact, when you think about the math table of multiplication facts, is that a confusing thing or is that a confusing thing? So here's how I teach them if somebody needs to learn them all. This is how I teach them to do it. So get you one of those slates so that you don't use a lot of paper and tear up a lot of trees. And start off, I tell them to start off with the 9s. So they put a 9 over here, a 9 here, and 81 there, and they do this little thing with the 9s. Same way I just did it. Then I want them to go to an 8 here, and this gets messy if you can't erase it. And they do the same thing. Then they go down to a 7, and I have them keep doing that. And my deal is have them do about 5 at a time. The reason I have them start at the 9s is because if you have them start to the 1s or the 2s or something like this, first of all, they'll try to slip in with their fingers and count them or resort to their old strategy. The second thing is by starting with the 9s, if they don't know their 3s and the 4s, they go, I can't do that. And then if I show them they can, all of a sudden I have another opportunity to break a belief, basically. So I do about 5 at a time, and then I stop and say, I do a review of those. Okay, what's 81 divided by 9? What's 7 times 9? What's 63 divided by 7? And just over and over again. Then I go do the rest of them. So I do like 4 through 0 if they need them. Then I practice those. And then I practice all the 9s. Once I think they have all the 9s down, then I repeat it over here and just start with the 8s. We don't have to do 8 times 9, so we can just do 8 times 8, 8 times 7, etc. And then we work through the 7s. And you just systematically, depending upon how fast they want them, how fast they need them, just systematically work through all the math facts.
When you said at a time, is that in one sitting, or is
Yes.
it each child dependent?
At one
also?
sitting. No, in a classroom, I have the kids do it with each other. So instead of me doing it, just have cooperative learning experience, and you can do it in small groups, but it's better if you'll do one-on-one, because then you know that every child is participating. If I say to all 4 of you, here's a math fact, you'll memorize it. Now, what is this? Well, one of you may be not doing it, and it's hard for me to track, but if I'm just doing it one-on-one, I know whether or not I'm getting a response or not.
That's so cool.
Yes, ma'am.
I just need some clarification. When you're talking about, are you talking about all the facts for 9, all the facts for 8, all the facts for 7, all the facts for 6, and all the facts for 5? That's a lot of facts. You're
Yeah.
talking about all of that at one time?
Mhm.
Because you're maybe talking 12 facts for each of those.
No, it's 9 times 9, 8 times 9, 7 times 9.
Okay, all right. I was thinking all the 9s, and then all the 8s, all the, okay. Thank you. That clarifies.
11, like 12.
Okay.
What's it, Scott?
Do what?
You go up till 11 and 12.
I personally don't. Some people do, and you can do that if you want to. And the reason I don't is when you're multiplying multiple digits, like two numbers by 2, that's a strategy. As far as I'm concerned, that's getting into another level. But in order to do that, you've got to have the 9s down. Now, some people go ahead and like to go up to the 12s. I've never understood that at all, why they do that. Well, then do it. You can do that with the triangles.
From the British.
No, I did 12 too.
I did up to 12 when I was in
Yeah.
school.
The matrix
All right.
goes by the 10. 11 and 12.